Hello, we're going to be presenting 2011 AP Calculus AV Free Response question number 3. Given the problem being an area of volume type of question, we will go through it as it is. It states, let R be the region in the first quadrant enclosed by the graphs of f of x equals 8x cubed and g of x equals sine pi x, as shown in the figure above. Starting with the first problem, problem A, it states, write an equation for the line tangent to the graph of f at x equals 1/2.
So we start, and we were given the equation f of x equals 8x3. And to respect of x, we will be looking to search the equation tangent to the graph of f at x equals 1/2. Now, in other words, when it states to write an equation tangent to the graph, it means to find the derivative of it as well as the slope. So, we'd be getting f of x being 8x cubed. Now, the derivative of that would be f prime of x equals 24x squared. And we will plug in x equals 1/2, giving us f prime of 1/2 equals 24 half of it squared, turning into 24 over 1/4. After getting that little equation, the result of 24 multiplied by 1/4 would be 6. Having that 6 is the slope for the equation tangent to the graph, going with the basis of y equals mx plus b, and having the graphs demonstrate that when x equals 1/2, y equals 1, we will have enough materials to be able to find the equation. So the point is 1/2 1, and our slope is m equals 6. Having that would be 1 equals 6 1/2 plus b. Solving this would give you 1 equals 3 plus b, subtract the 3. Having all this issued, we will end up with b equals -2. Plugging the b back into the graph, we end up with y equals 6x minus 2, being the answer for part A.
Now moving on to the second part, which is part B, we will be finding the area of R.
Moving on to part B, we will be finding the area of R. And so when we are given this, we're trying to use the method of integrals. And so we'd be finding the area of R equals to the integrals, starting from 0 to 1/2. So it'd be 0, 1/2. And in this, we're trying to find this little section, and it's stated to be top minus bottom. So whatever equation is on the top, which is g of x, would be subtracted by f of x. And g of x is sine pi of x, f of x is 8x cubed, so we'd go with sine pi of x minus 8x cubed. And with this, we're needing to find the antiderivative to have the solution. So the anti of sine pi of x would equal to -1 over pi cosine of pi x. And the reason for there being a -1 over pi is for when you're deriving cosine of pi of x, you will get negative sine pi of x. And the negative will cancel out with that, as well as the pi canceling out, so in solution giving you sine pi of x. So checking this equation will give you this. And the anti for 8x cubed would be 2 to the 2x to the power of 4. Evaluating from 0 to 1/2, you will plug in those numbers into the antiderivative. So we start with 1/2 -1 over pi cosine pi over 2 minus 2 times 1 over 16. Then we plug in 0 for the other side. It will be -1 over pi cosine of x times 0 minus 0. Going by the basis of this, we will start solving, and having this little equation, this already equals 0, and this already equals to 1. So we will have this -2 times 1 over 16, giving us -1 over 8 minus 1 multiplying times that, and since the negative times the negative over here would make it a positive, we end up with it becoming plus 1 over pi. This will be the whole solution to problem B.
And finally, with part C, it states, write but do not evaluate an integral expression for the volume of solid generated when r is rotated about the horizontal line y equals 1.
So for C, we're trying to evaluate an integral expression for the volume of the solid generated when r is rotated about the horizontal line y equals 1. And if we start off with f of x, we can just rotate this around. Having that set is kind of like a disk to say, and we'd want to find the radius or like the area of it having this height. And so the value for this would equal to having that one subtracted by f of x. And so the volume would go around being stated to be pi r squared, which equals to pi 1 minus f of x squared, with the depth of this, this being d of x. And if we want to find the same generation at volume with g of x, we do the same process, and we'll end up with a similar problem with it being stated as pi 1 minus g of x squared dx. And if we set that to be the volume of f of x is an integral, so we're trying to find the whole expression for this whole side from 0 to 1/2. So for the volume of f of x, it'd be an integral from 0 to 1/2 pi 1 minus f of x squared d of x. And the same would be when searching for volume of g of x from 0 to 1/2 being pi 1 minus g of x squared dx. And since both have the same bounds, have the same integration and such, we can have a process where we need to subtract f of x minus g of x, giving us the integral from 0 to 1/2 pi 1 minus f of x squared d of x minus 0 to 1/2 pi 1 minus g of x squared dx. We can combine these terms by, as previously stated, having them having similar bounds and integration and such. And with the pi, we can factor that out to have a equal of pi times 0 to 1 half 1 minus f of x squared minus 1 minus g of x squared dx. And if we want to go more in the simplified sense, we will actually plug in these functions, having the ultimate solution of pi multiplied by the integral 0 to 1 half 1 minus 8x cubed squared minus 1 minus sine x, well, pi of x squared with the d of x. And so this would be the whole integral when evaluating the volume without solving it.